Hello everyone. So today I am going to discuss about the RH criterion. This is the method in the control systems to know about the stability of the system. So now we are going to take this problem. So the given problem was the closed loop transfer function of a system is given by C of s by R of s, which is equal to k by s into s square plus s plus 1 into s plus 2 plus k. Determine the value of k for which the system is stable. So actually in the RH criterion method we are going to have the finding of the stability such that we are going to form a Routh array, and if the first column of the Routh array is having all the positive charges, if we don't have any sign changes, then the system is said to be stable. If we are going to have any sign changes, then the system is said to be unstable. So apart from that, we are going to have one more model in that, where we are going to find the value k, which is going to be called as a gain for the given transfer function. Now in this problem we are going to solve for the k, we are going to find what is the range of k, and we are going to state that for the being system to be stable, what is the range of k, we are going to find out. So for that, the first thing what we are going to do was, we are going to formulate first the characteristic equation, the closed loop characteristic equation. So now coming to the closed loop characteristic equation, so the given function, the transfer function was a closed loop system. So now if you consider the denominator polynomial, and when we equate this to 0, then that becomes the closed loop characteristic equation. So now the first step was closed loop characteristic equation. So the given closed loop characteristic equation was s into s square plus s plus 1 into s plus 2 plus k is equal to 0. So now we have to multiply it, and we are going to write this as a single expression. So and that is going to be given by s to the power of 4 plus 3s cube plus 3s square plus 2s plus k is equal to 0. So consider this as an equation 1, and this is our closed loop characteristic equation. So now for this closed loop characteristic equation, we have to form Routh's array. Routh's array need to be formulated. So coming to the Routh's array formulation, so we are going to first write the first column as s powers. So s powers need to be started from the highest power. So first s power 4, next s cube, next s square, next s power 1, and next s power 0. S power 1 and s power 0. So now we need to write the terms for the first row and the terms for the second row. So coming to this, the terms for the first row is going to be given by, so first coming to this, the first element coefficient, first row will be starting from this first element all the alternative coefficients, and for the s cube row starting from the second element all the alternative coefficients. So now when we write that, s power 4 is going to be having first coefficient was 1, and second coefficient was 3, and next coefficient was k. See here, s power 4 coefficient 1, s square coefficient 3, and next s power 0 coefficient k. So then after for the next s cube row, we are going to have 3 as s cube coefficient and 2 as s power 1 coefficient. And now next we need to form the second row, third row, fourth row and fifth row. So for that, what we need to make was, we need to go with the formulation of the row. For that, so first we have to formulate the s square row. So for that, what we need to do, so we need to take this term. So we need to multiply this term with this term and this with this divided by this term. So next, for the first element. So for the first element, what we need to do was, so we need to go with 3 into 3 minus 2 into 1 divided by, we need to represent 3. So and it is going to be given by 7 by 3. So now coming to this, the first element is given by 7 by 3. And for the same row s square, we may have here another column was also here. So we can formulate the second term also. And second term is going to be formulated such that 3 into k. And if we don't have any element here, we have to assume here we are going to have a term 0. So 0 into 1 and divided by the same term 3. So this will become the second term. So how we are going to represent was 3 into k divided by 0 into 1, which is minus 0 divided by 3. So the remaining term was, it will be k. So now we are going to represent the second term, which is going to be k. In the similar manner, how we have represented for the s square row, we are going to formulate for the s power 1 row. So coming to the s power 1 row, so we have to cross multiply the elements 7 by 3 into 2 minus k into 3 divided by 7 by 3. So if you formulate that, so 7 by 3 into 2 minus 3k divided by 7 by 3. So if you rewrite this, so we are going to have 14 minus 9k by 7. So this will be the element. So when we want to represent that, so we may represent directly here as 14 minus 9k by 7, and we don't get another term. Why? Because we don't have any another element which is here. So now coming to the same format, s power 0 row. So s power 0 row will be, here we don't have any other element. So this 14 minus 9k by 7 into k minus 0 divided by this term. So and this term and that 14 minus 9k by 7 into k divided by 14 minus 9k by 7. This term and this term gets cancel each other, and we are going to have only the term k. So now this is the first column of the Routh's array. So now coming to this first column of the Routh's array, we need to check we need to check whether for the what they have given in the question. So if the system to be stable, what is the value of k? So for the system to be stable, the main criteria should be each and every element in the column should be greater than 0. So for that, first thing what we have to do was, the first element what we need to make was k greater than 0. We need to make it for each column. So each for first column element, first column elements should be greater than 0. So we have to make first 14 minus 9k divided by 7 greater than 0. So now what happens here? 14 minus 9k, when this 7 goes this side, it becomes 0, and 14 minus 9k greater than 0. So for this, if you want to change this, if you want to make this 9k element as a first element, we have to multiply this with minus. So that should be done for both the sides. If you do that, so this will becomes 9k minus 14, and this greater than will becomes less than 0. So now we can make it as 9k less than 14. So k should be less than 14 by 9. And another element what is here is k, which is greater than 0. So this was the second case and this was the first case. If your k value is less than 14 by 9 and if your k value is greater than 0, then the system is stated to be stable. So now coming to the range of k for the system to be stable, range is given by 0 less than k less than 14 by 9. So this will become the range of k for the given problem. Thank you.